Alright, well, we made it to the final video in the Vise Top series. We're going to be back with part one, which is where we started and we faced in Chamfer the Ends. Um, Little overview shot of the setup. So we're using the indexing head. Sometimes I'll call it the super spacer. Um, this is going to be great because I'll be able to get my two milled flat surfaces perfectly parallel to each other. So I decided to go ahead and show the edge finding. Um, for the first milling steps, you really don't need to edge find this part, but it's going to make the drilling and tapping of the quarter 20 hole a lot easier. So I just go ahead and start with the edge finder. So I touched off, 0 the readout, move over 0.1, 0 the readout, and then I'm going to go ahead and go to the center of the part and then find the y-axis. Now this machine probably had a drill chuck in the spindle, and that's why I'm using the edge finder now. If it had an empty spindle, I probably just would have put the end mill in there and then touched off on the top of the part and then touched off on the face of the part with a rotating cutter and just zeroed my dial of my knee and my dial of my y-axis or the digital readout. I want to minimize my tool changes. So I just raised my spindles against the stop. I raised the knee until the rotating cutter touched the top of the part. I zeroed the knee and I make the correct adjustment for my depth. Now I take this in 3 passes, and I probably just looked at the distance and went like maybe 50 thousandths shy of the full distance on my second pass, and then take a small finish pass. I'm not really sure. I filmed this a while ago, so because you could do this in just 2 passes at your finish depth as well. So right here on this pass, I probably could have just went all the way to my finish length. But like I said, I probably went about 50 thousandths short or something. And every cut is a conventional cut. That's why I'm returning the cutter to the left side of the part. And now here comes the super spacer indexing. I turn off the spindle before I start rotating the part around, and that's what you need to do as well. Make sure you retighten the clamp, otherwise you'll find chatter happens. And I just simply repeat the same cuts I did on the other side. Everything worked pretty good. So while this is going, if we weren't using the indexing head, there are other methods of keeping track of your surfaces, but this is an easy way to do it, and I like to show you all the different work holding devices that are available. It's important that you understand how to make things efficiently, but I could have cut this flat in a standard vise with the part on a parallel, then rotated the part and used an adjustable parallel underneath the previously cut surface to level that part. That would be my other preferred method, but this is clearly faster, and I am very confident in the accuracy level. So I'll do a little just kind of spot drill with the tip of a center drill in preparation for my quarter 20 threaded hole. And I'm just going in the tip section because I'm looking for something that'll guide my tap drill to the correct location. Use the charts to determine your drill size. There is another method, but just let's keep it simple. Walk over to the chart. You can see that one that's hanging up in the background, the Cleveland brand one. Look at your size of tap. Use the drill bit it says. So what I do here before I tap the hole is I'm taking advantage of this setup, and I'm going to countersink both sides of the part before I tap, because then when I take the part out, all I have to do is wipe off the bluing and I have a finished part. If I were to just tap the hole before countersinking it, then I would have to deburr the hole, and I would likely deform the entry of the hole and have to kind of run the tap back into the hole by hand. So I'm saving some time here, and you'll end up with a more professional looking part. And I didn't set any depth stops or anything like that. I'm just coming down and going by what looks good to the eye, which when you're learning means sometimes you end up with countersinks that are too small and too big. Make sure that when you're doing something by feel or by eye, it's at the appropriate time. And I go ahead and I power tap using the drill chuck. A quarter 20 tap, probably not going to spin in the chuck if you tighten the chuck tight. But larger sizes, we'll always go and use our tap drivers. But I feel like on this one here, this is a pretty safe, low risk operation. I get to the bottom, you see the tap is coasting freely, and then I reverse the spindle and use very light upward pressure so the tap clears the part. And that's actually going to wrap this all up. Just make sure you clean, deburr, inspect your parts before you have them graded, because you don't want to leave extra material that you could have cut off or other silly mistakes.